All right. Hello and good evening. Welcome, everyone. Happy CircuitPython Day. Hope everyone is having a great day. Let's see here. I'm going to make sure that I can see the chat windows and then get the show on the road. Let me put this one back here. How's it going, squid.jpg, as well as Deshipu? Nice to see you folks today. Hope you're having a nice CircuitPython day, so welcome. First of all, for anybody that might be new, my name is Tim. I go by FoamyGuy on GitHub and Discord. I typically stream on Saturday mornings at 10 a.m. Central Time working on CircuitPython stuff, and I will be back in the morning tomorrow to work more on the game that I will work on during this stream as well. So first of all, if you are new, thanks for checking out the stream. Thanks for watching along on CircuitPython Day, which is the first piece of business for the day. It is CircuitPython Day, and there is 16% off code for most of the products on Adafruit.com. So if you want to support CircuitPython and Adafruit and you want to get yourself some nice 16% off today, you can do it over at Adafruit.com. Use the code CPD16, which I have put down there on the screen as well for your convenience. So head over there, get yourself some toys. And yeah, I think most of the folks watching are likely to kind of know what CircuitPython is by this point, so I won't do the very, very high level introduction of CircuitPython, which I typically do at the beginning of the streams. But yeah, we are working on CircuitPython. In particular, I am going to be working on a video game on the Pimoroni Pico system, which is this device right here, and I have it pulled up over here. You can see it running the current version of the code there as well. So this is a device that runs CircuitPython. It plugs into your computer, just like all the CircuitPython devices. It shows up like a thumb drive. We can edit the code on there. This one's sort of main feature set is that it's not really a generic microcontroller with a bunch of I/O pins, but instead it's a fully sort of contained device, a little handheld gaming device with a 240 by 240 display, the buttons on the right and then a D-pad on the left, and it's got a battery built in and a couple of other features as well, a speaker and some stuff like that, which is really nice for games. So that's what I am working on. Let me catch up on the chat here and say hello to everybody. How's it going? To C. Grover, some nice. Paul Cutler. Let me see. Yano. I'll try to get that one correct again. Some nice, and JBC. Nice to see you folks, and I hope you're all having a nice CircuitPython day. Also over on YouTube, Beata Graph. Nice to see you as well. Hello and good evening, my friend. So I am going to jump right in. I'm going to show you what I have so far, and then I'm just going to dive right in to adding more to it. So I'll restart the code that's running. Actually, I don't think I have TO running yet. Let's do that. And then you can see from the beginning, it spawns the full level. The ball bounces around. So the game that I'm going to work on during the stream is a clone of a type of game called Breakout or Brick Breaker. I've seen it go by many different names. And the gist of it is the ball bounces around. There's a paddle at the bottom, which we control with the D-pad, or just the left and right, really. The goal of the game is to bounce the ball up and break all the bricks that are at the top. There will eventually be a certain number of lives, and so when the ball hits the ground down here, if you don't hit the paddle, then you'll lose a life, and if you lose 3 or however many it is, then the game will be over. And then the ball breaks the bricks. Each time it hits one, it will break the brick, and then the sort of twist on the game that I've added is the B button will change the color of the paddle. So you can see I can change the paddle down there. And then when the ball hits the paddle, it will change to whatever color the paddle is. And then my intention is to make it so you get bonus points whenever the ball breaks a brick that is the same color as the ball. So that's kind of the idea I have in mind for this, but right now only the sort of like ball flying around and bouncing and breaking bricks is implemented. There's nothing else like score or anything else. So that's what I'm going to do during this stream. If you are interested in the code for this, it is on GitHub, github.com, foamy guy, CircuitPython Rainbow breakout. I pushed it up earlier, and I'll push up the changes that I make during this stream, and then after I work on it again tomorrow, I'll push out the update for that as well. So if anyone wants to work along on the same game, or if anyone's interested in just making their own version of Breakout or taking it in a different direction with a different twist on it, please feel free to grab the code for that and do whatever you like with it. Pretty sure the first instance of this game was on Atari 1976, was called Breakout, written by the Woz. Yeah, I think you're right. I was looking into this a bit when I chose this game, and yeah, I do remember reading that Wozniak was the one that coded the first version of this. So I do think that's correct. Okay, so I'm going to show you the code that I have real quick, give you a quick run through, and then we'll dive in and start messing with it. So I'll go kind of from the outside in. I have the CodePy file here, and there's really not actually that much in the CodePy file. It has an FPS target. It has a delay which divides that target to get to a seconds value. It has a milliseconds value that's 1,000 times the number of seconds. It grabs the built-in display because this device just has a built-in display. We don't have to worry about init sequences or pins or anything like that. It's already initialized. We have a game object right here. So I've created rainbow breakout.game. That gets imported. We'll dive into that in a minute, but for now what we see, we're giving it the size of the display. It's given us back an instance of game, and we're able to set that instance as root group, so that tells us game also probably extends group or tile grid, which we'll see when we get into it, that it does extend group. We have a last tick variable that's gets set to the current time. We get a variable set to the current time each time through the main loop. We check if the current time has been, we check if the last tick was the delay amount of time ago, and if so, then we know we need to make the tick again. So we do that, we set the last time so that we can update and check, next time for the next FPS delay length of time away. So all the magic happens inside of game.tick and game. If we go into their game first, we can see extends group. It holds all the objects that we show on the screen. 78 was Super Breakout. Nice. Yeah, thanks for the Wikipedia link there as well in the Discord if anyone's interested in some more of the history of the different versions. So game extends group. Group, of course, is the display.io class, which allows us to put this object onto the display. We have a display size. We have a list that's going to hold all of the balls. Right now there is only a single ball, but I have in mind the idea of multi-ball, so I made that a list in kind of preparation for adding multiple balls. We do have multiple bricks, so that's a list as well. All those things at the top, all those things at the top are the bricks. It's been running for a while in the background, so it's broken most of them, but those get put into this list here. We create a ball, we add it to the ball list. We set the speed initially to be positive 1x, negative 1y. We'll probably tweak this eventually to make it to where you have to press a button or something. So initially the speed will be 0, but right now it's defaulting to sort of up and diagonal. I guess up and right, I think it would be. We create a paddle, which we'll go and we'll look at the paddle class. We'll look at the ball class as well here in a minute. We go and loop 7 rows by 10 columns. We create a brick for each one of those rows and columns. So brick class we'll look at here in a minute as well, but the basics of it are an X, Y, and a color index. So we're giving it a location on the display. We're giving it what color do we want that brick to be. And then we're going to go and append onto self. So onto the group instance, we're going to append the bricks dot shape, which is the actual vector IO object. In this case, a rectangle, because this is representing the bricks. So we're going to add that to our group so that it gets shown on the display. We're also going to add the paddle shape to our group. We're also going to add the ball shape to our group. And that is it for the initialization. Then we just have the tick function, which gets called every frame of the game. We loop through all the balls. We call ball.tick. We self.paddle.tick. We call tick on the paddle. We loop through all the bricks. We call tick on each one of the bricks, but this one is actually a little bit different. We also check the results of tick, it will return true if the ball collided with that brick. And then if it did collide with that brick, we actually break out of this for loop because we want it to be that during one single frame of the game, the ball can only collide with one brick at a time. If it happened to be touching two, it won't count it because of this. Now, you could make the case maybe we want it to, maybe we change that later, but for right now, that's what this code does. It makes it so that the ball can only break one brick per frame of the game. Okay, so that's game. So let's look at paddle. I think is probably maybe the second least complex or something. So let's do that. So paddle, it's got some defaults for the height and width, the X and the Y. It creates a vector IO rectangle. It puts that on self.shape, remember, which is what we added to append to get it to show on the display. We set the color of each one of those things based on the color it asked for us to use. We default the paddle to speed 0, so by default it's going to be not moving, it will be still. We set the speed to 2. We set the previous state to gameControls.button, so this is going to be how we're going to listen for all the buttons like the arrow keys and the A, B, and all that. So that's it for the initialization of the paddle. Inside paddle.tick, at a high level, what we need to do is listen for the buttons and then move the paddle if the left and right buttons are being pressed, which is exactly what the logic in here will do. It says current state is equal to the gameControls.button. If the right button is being pressed down, then we're going to go inside of here. We're going to say if self.right is less than the game display game size width. So if we have enough room basically to move right, then we're going to go ahead and set the speed of speed X equal to self.speed, which was this value here, 2 in this case. So now our speed X is 2. Same thing for left. If the left button is down and we have enough room to actually move left without going off the display, we set speed X to negative speed. And then we say current state. So basically this is like debouncing to make sure that we, although I don't know why we have debouncing because you can hold it down. Oh, this is the B button. That's right. Yeah. So we debounce the B button. We don't do any debouncing on the arrow keys. Those are just hold them down and the thing moves. The B button, though, to change colors, we do want debouncing. Otherwise, if you would press it, it would change very rapidly a bunch of colors real fast. Yes, for sure. Thank you, Toddbot, for dropping the link there. Would a game like this benefit from monotonic NS compared to monotonic? Possibly. It's very possible that it would. I have not done really very much testing around the actual efficiency or trying to push the FPS as high as we can get it. And the faster we can refresh, the faster we can get through each frame, then the faster we can do each frame, and then it might start mattering those smaller units of time. One thing I did do, which is in the somewhere. No, I guess I'm wrong. I was going to say one thing I did do was use Adafruit.tix, but that's actually not true. I didn't. I must have dreamed doing that. But that one thing we could do is use Adafruit.tix, which would help with that a bit. Now it has milliseconds as well, so you still have the choice between milliseconds and nanoseconds. But it would help us with the rollover if we were to leave this thing on for a long period of time. All right, so basically debounce the B button. When the B button gets pressed, we're going to change the color of the paddle by setting the color index on its shape. That's a vector IO construct there. So shape is a rectangle, which has color index, so we can set that. And we're just cycling through all the colors in the palette. If the right button is not pressed and the left button is not pressed, then set the speed to 0. And then finally, we go shape.x, the actual x property of the shape itself, plus equals the speed x. So if speed's positive, the shape is going to move to the right. If speed's negative, the shape's going to move to the left. And if speed is 0, then the paddle will not move at all. Then we're going to loop through all the balls. And again, remember, I currently only have one, but this is just in preparation for multiples. We loop through those. If the ball is colliding if self is colliding with the ball, so if the paddle is colliding with the ball, and if the ball speed y is greater than 0. So if the ball's moving down and it's colliding with the paddle, we're going to go and flip the speed. So speed times equals -1, which is going to make it positive if it was negative, or negative if it was positive, and then change the color of the ball to the color of the palette. Update the previous state so that we can use it back here for the debouncing. So that's it inside of paddle tick. We have is colliding here, which is basically the geometry that will check if the paddle is colliding with the ball. This is still the old version, which I have since learned actually a better way. Maybe we could do this without the square root here. So when I do get into actually profiling the efficiency and trying to squeeze it out each millisecond that we can, one thing that we can actually improve upon is this, by taking out the square root and then getting rid of the squares inside of here. Hug report to the Shipu for that. Yeah, good idea on that one. And I will eventually do that. For now, I want to focus on the game elements more so than the fine-tuning, but I definitely intend to go through and do some stuff like that so that we can hopefully speed up how fast the game can run, make it nice and smooth. If the distance, so this is still just part of the collision, basically. So this is colliding. It's checking the paddle size and location against the ball location and radius, and then it's able to tell whether the ball is touching the paddle or not. If it is, it returns true. If it's not, it returns false. Everything else here are just kind of convenience properties for X, Y, width, height, and then also top, right, bottom, and left. Those will give you the pixel value of each side of the paddle. Width and height, pretty self-explanatory. That'll give you the size of the rectangle, and then X and Y will give you the location of the rectangle, the top left. Ball, pretty straightforward. It's got some defaults for a size and a location. It creates a circle instead of a rectangle. It does set the color index on it to whatever the default is, number 1. Starts out inside of a knit on 0 speed. It's got all these helpers, left, right, top, bottom, again, that are just returning the pixel coordinates of that side. It's got the tick function, so this one is going to go and say shape plus equals speed x, shape y plus equals speed y, so move the ball by the current speed, x and y. If we hit the right edge of the display, turn the x value, positive or negative, flip it around. If we hit the left edge of the display, same thing, basically we want to bounce off the walls. If we hit the bottom of the display right now, we are just bouncing, but eventually we want to lose a life. And if we hit the top, it is just bouncing. And then we just got convenience properties, radius x, y, a couple others. Last one is brick, and then we'll jump into the actually doing some more coding. Brick, inside of a knit, it creates a rectangle. It sets up the color index. Inside a tick, it will go through the list of all the balls in the game. It will check the current ball to see if it's colliding with this brick. If it is, then it also ends up checking which side of the brick it's colliding on, whether it's the bottom or the top or the left or the right, which also gets returned as part of this. And so basically, in this case, when it hits a brick, it gets rid of the brick by calling bricks.remove and game.remove. And then it also changes the direction of the ball to make the ball bounce, and that's going to be based on whether it hit the left and right sides of the brick or the top or bottom of the brick will determine whether it flips in the X or Y axis. And then the actual logic inside of is colliding is mostly just math, and it actually does 2 checks. It checks if the ball is intersecting with the rectangle. Because remember, we're inside brick, so self.shape, that's the brick shape. So we're saying, does this brick intersect with the ball? If that's true, then we go and actually do another check right here to check which side we're intersecting on. I'm almost certain there's probably a more elegant way to do this, but geometry is not necessarily my strong suit, so this is what I came up with. It does the efficient check first, and then it does this sort of gnarly check each side individually. To determine which side we hit. This is a different version of it, which we may swap back to eventually. And we have all the same properties that are just convenient, you know, X, Y, width, height, top, right, left, bottom, all of those, which are then used by some of the code in here. Okay, all of those things come together to give us what we have right now, which is just this ball bouncing around, breaking the bricks. So let's start adding some more stuff to this. For one thing, I want to add lives and make it so that when the ball hits the ground, you lose a life. I'm going to go ahead and put that on the game, I think. So we're just going to say self.lives equals, we don't want to start on 0, though. I'll start on 3. Oops, I scrolled the chat here. Let me get that going. Let's see. No, we don't want to move the squares inside the parens. Squares would be the things we compare to. Right. Inspired by my last stream, I set up to start exploring the De Luani triangulation. Interesting. So I haven't heard of that one so far. I just random points on the triangles. Oh, nice. That's cool looking. I just picked up a round display thing. With the CircuitPython Day discount earlier. Yes, I should mention as well, intersects, that is a new thing, by the way. Where was that? That was in bricks. Intersects right here. So self.shape, that's on the self.shape. This is a brick, so that's on rectangle. Intersects, that actually does not exist just yet. That's in a PR. I don't have the tab pulled up, but it's in a PR into the core. And it will still probably change because I think it's actually would be better to not be like rectangle dot intersects and then it takes a ball. Rather it takes a circle. I think it would be better to take the mathematical values. So I think it should take like XY of the rectangle, width, height of the rectangle, and then XY of the circle, and then radius of the circle. It's a lot of arguments, but it would be better because that would mean we could use it with stuff other than vector IO. If you are interested in that, you can take a look at the PR. If you have ideas on how that should work or where it should belong in the core, feel free to leave a comment there. For right now, it is implemented as like rectangle.intersects and it accepts a circle, and then the vice versa one exists as well, although this code's not actually using it yet. Okay, so we're going to go lives 3. We're going to go whenever the ball hits the ground. Well, first of all, I want to show the lives. I want to show it. So first of all, I'm actually going to move the bricks down. Right now, the bricks are pretty close to the top of the display. I want to move those down just a little bit because I want to have room for some text at the top, which is going to be our score and our lives. So I'm going to move those down by, we're going to make a thing called top padding. I'm going to start on, I think, like 8, maybe? See how that looks. So the Y right here, we're just going to do all the stuff we were doing before, but also plus the top padding. Which this doesn't want to do that way. So that should move those down. Yeah, we got a little nice row above now. Let's see if that's enough room to actually put some text. Self dot lives label equals label, which we'll just use the default font. Text equals self dot lives. Maybe should we say, I'm just going to do the number for right now. Text equals that. We need anything else? I'm going to start with just that label. We do need to import it from Adafruit display text.bitmap label. I think it's like this. Import label. Let's see if that crashes. Incompatible MBY file. Okay, so we need to, yeah, and that's on display text. So let me just delete display text, get the new one, circup install. Object int has no find, bitmap label init. I probably gave it the wrong stuff or something. 24 doesn't want to show me the see, I probably have done this wrong. Actually, it looks the same there. Int object has no find. Replace tabs. Oh, I think this needs to be a string, actually. Yeah, okay. I gave it an int and it doesn't like that. Okay, I don't know where that ended up. It's probably not on the display. So let's also go, well, also I didn't append it. So self.append, self.lives label. Let's do that. Self.lives label, label. I like anchor point, anchor position. So anchor point, I'm going to say is the right side. I want to put this on the right, and then I'm going to put the score on the left, I think. Or should we do it the other way? Let's do it the other way. Let's put the score on the left, on the right, and let's put the lives on the left. That feels more natural, I think. Yeah, I think so. So anchor point, this one I'm going to use 0, 0. And then we're just going to say lives label, anchor position. We were talking about Scott was talking about the LLM stuff earlier. I've been using PyCharm and CLion, and I've been relatively pleasantly surprised with some of the completion that it's got. So we'll say this one I want to be on the left, so I'm just going to give it like a little bit of padding. We're just going to go like 1, 1, so it's not on the very, very edge. Okay, so there's that 3 up there. It's not quite enough room, actually. The brick that's right below that looks like it's on top of it. So let's move those a little bit further by increasing the padding. Okay. Yeah, I think that's pretty good. So let's make one for the score while we're here, since that's pretty much a copy-paste. We can't just do that, though. Let's see here. Score. Sakura? Anchor point is also the rotation point. We don't have arbitrary rotation for labels currently. There is some support for rotation, but it's only on the 90 degrees. Like you can have one, downwards, or you can have one backwards, which is like 270 or whatever. And there's a few others, I don't remember what they all are, but there's no just arbitrary angles. You can't just set 45 or anything you want. And the support that it does have is I don't think it rotates around a point. I don't think you can tell it which point to rotate around. It just always rotates the whole string, I believe. I will say, just like Scott, I'm totally down for questions and stuff. I don't know nearly as much about the cutting edge inside the core and the newest chips and everything, but if you have questions about libraries or display I/O or anything in that vein, feel free to shoot. I'm happy to go on tangents as well, truthfully. Okay, so new label lives. We're not going to be on lives. We'll start this one at 0. We'll just say you start at 0 points. Anchor point where we want this one. So this one I want on the right side. So I'm going to say 1.0 for X, but I'll leave Y on 0. And then the position, I'm going to say Y is still 1, but the X is going to be display size 0 -1. So we want to put that over on the right edge. Why use anchor point, anchor position, tuples in setting X and Y? Just convenient. Well, I shouldn't say convenience. The word I meant to say is preference. Just preference. I like anchor point and anchor position. It's just how my brain thinks about positioning. But you totally could do X and Y as well. I will say, like, the case where, like, one of the cases where I really like anchor point and anchor position instead of X and Y is like right here. We're not necessarily like manually trying to figure out the correct X, right? Because this point would be kind of a weird point, right? It would be like the width of the display minus the padding we want minus the width of the label. And the width of the label is, it's possible to get with bounding box, but then it would make this equation a bit more, whereas anchor point gives us the ability to map against that right edge. And then we don't have to worry about subtracting out the width of the label. It will do that for us internally. Yes, and yeah, because we can give it display size here, then it can also be resolution independent. If we move this game to a smaller display, we're still going to end up with our label on the right edge of the display, which is very nice. Okay, so scores over there, lives are over there. Let's make it so lives count down when the ball hits the ground. That is in ball tick. Ball tick, so if bottom, so right here we bounce. Instead of bouncing, we don't want to do that anymore. Instead, we should just, I think, set the speed to 0, both of them. So the ball will stop, and then we will lose a life. Self dot, well, but it's not self, it would be game, which is getting passed to us right here. So the game object gets passed in, so we go game. Let's see here. Game.lives -1, minus equals 1. And then we want to update it. In fact, maybe we should make this a property. One of the cool things about CircuitPython is the ability to make stuff like this a property. So let's actually call this self._lives. Let me do this actually. Rename lives to _lives. Okay. And then make a property def. No, not, well, yeah, def, but property def lives, return lives. See, the completion here is pretty good on some of this boilerplate stuff. Lives.setter, again, good. Def lives, yep, new value. I like new value here, but that's preference. Lives equals new value. Okay, and then also when we set it, let's update the label. So lives label here. We just need to, we might as well grab it extra. Lives label.text equals the new lives value. Okay, so now when we use the property, it's going to update the label for us if everything works right. Oh, okay. Also, it keeps going down, so we need to reset to kind of a paused mode or something. We need to reset to a paused mode. I'm actually going to make some new variables. State paused equals 0. State playing equals 0. I'm actually going to make some more as well. State waiting to start. So this will actually be where we begin at the beginning. Paused, and then we're going to also have a game over. Oops. Okay. And then we can just very easily inside tick if, well, we want to put a state on the, we want to put a state, actually, right inside tick for game. We do need to put a state here, waiting to start. If self.state is playing, then we do this stuff, otherwise we don't. So now the ball should, now the ball should not move anymore. Yeah, so it just spawns right there, it doesn't move. Let's make it so that when you press a button, it will go ahead and move. Let's see here. So right now our controls are inside the paddle though. We're gonna have to change that. So right now controls are in here. State game controls. I'm going to change it. I'm going to cut this. I'm going to put this on game. Game controls, we're going to have... So you don't have to initialize that one? Okay, yeah, looks like you don't have to initialize that. Just import it. So I'm just going to go... game controls. So game controls, this is a library. This is a library that I have on GitHub. I should put this in the bundle, honestly. Put this in the bundle. It's not there right now. This is a library that abstracts video game buttons into one single library, so you can make your game using game controls library, and then all the devices that are supported, it will just automatically give you access to those buttons without you worrying about, you know, is it on pin button A, or is it on pin 20, or, you know, is it the up button, or is it a joystick, or like this tries to abstract it so that you have one interface, and then, you know, each different device that's supported has the definitions to actually go and map each button together. Let's see here. Love the Baltics, great folk music. Need to know the size of the box. Yep. Okay, so control. So that's on game now. So then inside of here, previous state. We don't actually have access to previous state, rather to the game object inside of init. So I think what I'm going to do is just set this to none instead. And then here we do have access to game, so we could say game.gameControls. And then after the first time, previous state will get set to current state. So we just need to make sure here, because this is really the only place where... This is the only place where we access previous state. So we should just say and self.previous state is not none. So if it is none, then we won't go and try to access it. Okay, let's see if we can still move the paddle. Nope. Yeah, it's not even render. Pico system game controls has no object game controls. 21. 21 of game. Did we do that wrong? I think we did that wrong. Yeah, I don't know. That might have been the autocomplete. So we just want that to be equal to the module. This is one where you don't initialize it. You just import it, and it initializes itself. Okay, that is not working, but actually that makes sense because we're in the waiting to start, which means the game tick is not getting called. Yeah, which I think I'm okay with for now. What we're going to say is if we are waiting to start, then we're going to check for a button press. Let's say the A or B button, actually, since that's the one that changes colors. Let's just keep it the same. So when you press the B button, we will start the game. Do we need to care about the previous state? Let's try without, but we might need to. I'm not sure. let's see, we're in the game, so self.gameControls. So say if the B button is pressed, then we go to playing, which then means the rest of the tick will get called. Nope. Object isn't subscriptable. Oh, we need to call buttons. Stop buttons, button, actually only. Then that's like that. Oh, but it's not self. Okay, there we go. So now the game starts. Left and right do work. Breaking bricks works. Losing life kind of works, but we still get stuck. And it still just counts down infinitely. I guess we didn't change the mode, did we? We want to probably go to like a... We want to probably go... Do we want to go to paused or back to waiting to start? I think we want to go to paused. We also want to move the ball so that it won't be on the bottom anymore, which will make it stop counting for infinite. Alright, so when we lose a life, let's also go... Actually, we can just do X. We don't need shape because of those properties there. Okay, so put those back to... It's hard-coded right now. I should probably change that to not be hard-coded, but for now I'm just going to leave it. So let's move that to there. Let's also go game.state equals... game.state paused. We should be able to do game like this, right? Or no? Oh, because we're not importing it actually. Okay, I see. Just do that. Okay, so now the ball should move, which should by itself stop it from counting down, but also the game should go to paused, which also theoretically would stop it from counting down. Move out of the way. Okay, ball resets, lives go down, we are in paused mode. We set the speed on that to 0. Where was the initial speed on the ball getting set? Oh, right here. Okay. I think we should just not even do this, actually. Let's just, those should just stay 0. And then that should happen when we start the game. Which is here. So no speed at the beginning. Speed starts at the same time as we switch to playing. And then we can also handle the paused right now as well. If state equals state paused, then we're gonna go more or less the same stuff as this. I wonder if we should have, maybe we should make another state that is like distinctly lost a life and waiting to start, or maybe we should just go back to waiting to start. Yeah, I think I'm leaning towards just going back to waiting for start. That way, because I think we could use like one of the other buttons to actually let you pause the game. And in that case, we wouldn't want to manipulate the ball speed, right? Because pausing shouldn't change like how the ball is moving. Let me catch up on the chat here as well. Sorry, I've been bad on the chat. Is there a way to map your own buttons to a generic dev board? I don't know off the top of my head. The library is relatively small, though, so it should be pretty darn easy to hack it together with any board. You basically would just add one of these things, add a class for it. There is a base one here. I mean, I guess you could use the base one directly if you had a different device. But yeah, it's fairly straightforward to add a different device to it. Pretty sure Unity does something like that constructor also in the function, like 2 parts at startup. Better for isolation and testing. Although I've seen it done as reset type function that could be called upon start lives. Yeah, that could be cool, do a reset. Just had an idea. I'm using hues on another project about using colors, sort of a third dimension. Oh, nice. Keeps counting down because the ball's still in the bottom. Yeah, totally. Thank you. Okay. So let's actually make it when you lose a life, it goes to waiting to start instead of paused. So then we should be able to start the next life by pressing B again, I think. Has no attribute waiting to start. State. I think I didn't do state waiting to start. I almost want to, I should move the bricks so they don't go up that little channel there. Okay, one thing is you can't move right now in between. We might, I don't know, maybe we want to make it to where you can move the paddle. I feel like that's relatively customary in this style of game. Okay, but the B button did start us up, so that does get us going. And we can hit the paddle. We don't lose a life, which is nice. And then if we let it hit the ground again, we will lose a life. We could go again and we would... Okay, it reset. I would need to probably turn off auto reload if you wanted to really play the game while you had it plugged into a computer. Let's scooch those bricks over slightly. This is kind of just random. But we have a bunch of space here and no space here. Left padding. Let's try 10 and see what that looks like. Whoops. There we go. Now it's a little more even, I think. Does it still go up that column? It doesn't. Okay, yeah, I think that's better. I think that's better. Okay, let's add a score when you break a brick. I'm guessing the feed probably cut out. Okay, hopefully we didn't cut out for too long. You might, I know sometimes on YouTube or if you're on Twitch or whatever, sometimes you got to refresh. If your stream broke, try refreshing. Obviously, you can't hear me if your stream broke though. So, but yeah, I totally just saw the OBS ramp all the way down to 0 frames and then bring itself back to life. So. Let's see, where was I at? Okay, yeah, colliding. So let's say tick, whenever we tick, if we are colliding with, the brick is colliding with a ball, then we want to say, we don't really care which side we're colliding on here, although it is, We don't have necessarily an easy way to, so we kind of have to duplicate it, unfortunately. This is weird, huh? How this is inside here. I feel like this should probably be like that. I mean, yeah, I think. And then if these return early, we definitely have to have it duplicated. It might be worth refactoring this section a little bit, but for now, I'm just going to do the duplicate. So here, if self.shape.color index is the same as the ball, so that would be the current ball.shape.color index. So if it's the same, we'll do it one way, else we'll do it default. So we'll just say game.score plus equals 10. Or maybe should we do 5s for those? Then 25 for that? And then we should make properties for that so that it will update the display as well. Same way we did this pretty much. We will need to change score to be underscore. Actually, I never even made a score, so that's convenient. We don't have to change it because I didn't make it. Start on 0. Found it helpful to place a text label on the screen to show the current game state. I also stopped using numerical values for name definitions, started using strings. I have used strings in some of them. I think you told me that tip before, and I have used that in a couple of games. I will say it is nice when you can print it out and see what state you're in without knowing the mapping. I will say that is kind of nice. I mean, as you can see, I do still tend to like just if I'm going default or whatever, the way my brain will go is with numbers typically, but let's see, this will be the score label. But yeah, strings is nice as well. Fully agreed. And then I will eventually, yeah, I probably will eventually add a label for the state. Would be nice as well, so that when you're paused, it'll have a little word that says paused. That'd be a good idea as well too. So string getter will get the string, updater will set the new score, and then it will update the label as well. And we did plus this, so this should work now, I think, right? This should count some score. Nope, didn't work. Let's see. Why does that not work? So are we updating the score value and just not updating the screen, or are we? And I mean, that's if and else, so it's not like, even if the logic was wrong, we would just fall back into else. Oh, I've only put this on one side. Yeah, I was saying we need to duplicate this, and then I didn't actually duplicate it. And we're almost always going to be hitting from the bottom, truthfully, as well. Maybe we should turn those around. There we go. I don't know why we got 8, though. 8 seems kind of random. Also, it's not working on every one. Okay, well, that's a little weird. We have plus equals. Where would 8 have came from? Hmm. Okay, let's just start trying to. Validate some assumptions here. See if that prints. Score property is still using live_def. Ah, thank you. So the 8 became 5 plus 3 and then got stuck. Oh, that was auto reload, I think. There we go. Okay, let me try to get purple. Nope, too slow. This will test if this works. So we should get 25 if it does. Nice. Okay, let's make it so, let's work on actually game over. So when we lose a life, it goes to waiting, and then it restarts when we press B and we lose a life, and it goes to waiting, we press B and it restarts and we lose a life, and then right now, there's no special anything. It will just keep going and let us go into negatives. But what we want is when you reach... Well, do we want to say 0 is your last? Yeah, I think we'll say when it's showing 0, you're on your last life. So actually, when it goes down to -1, that's when you will be actually on game over. So where should we do that? Should we do that in... We could actually do it in the lives setter. Does that make any sense, though? Should we do it there? It doesn't feel correct to put extra logic inside there, honestly. I think we should probably do it where we check this, which is here. So then we'll say... Yeah, so let's say if lives is equal to... So we can actually say -1. We want to make it so that you get to use your last life, basically. That shouldn't be there, though. That should be in the else block. Okay. If you are on the last one, then we're going to go to game over. And then eventually what we would do is when you're in the state game over, we will put a thing on the display that shows that you are on game over. And then we will also make it so when you press a button, the game will reset and you can play again. So this should be our last life. I notice we're changing here as well. Oh. No object state game over. Is it one word game over? Yeah. Although this thinks it's spelled wrong. Yeah, let's change it. It didn't actually suggest something to change it to. Okay. Wait, what? Oh, okay. Okay. Let's see. I will probably wrap up here pretty soon, just to keep it to about an hour. I know most of the streams today were about an hour, so I'll probably wrap up here pretty quick. If anyone has questions, comments, ideas, thoughts, now's the time to share them. If you would like to see more work on this game, I'll be back in the morning tomorrow over on my own channel. I think we just auto reloaded at the exact end time. I don't think that crashed. I'm pretty sure that was an auto reload. Let's just try to get through here again to the end. Tomorrow morning, 10 a.m. Central Time, which is not the time zone stuff is usually built in, so be wary of that. It just is the time zone I'm in. 10 a.m. Central, which is 11 a.m. Eastern, and what is it, 8 a.m. Pacific. I'll be back here, and then I will drop links in the live broadcast chat when I get started. And tomorrow, I am going to keep working on this game. So if you want to see some more functionality get added to this, then that's where you can come back tomorrow. For now, I will bid you farewell. I will say thanks again, everyone, for hanging out all CircuitPython day. I hope everyone had a great day. Remember is it that way? Yeah, the code down there is good until I think it said midnight, so you've got a couple of hours still, but you should get your order in if that's something you want to do. CPD 16 for 16% off on most of the stuff at Adafruit. Yeah, thank you for watching along. It's been fun for me. I hope everyone else had fun. I will see you all later. Thanks.